A few days ago, some colleagues from University of Canberra published a very important paper in Nature relatively to the seismic waves in the Earth's core. What they found is that the velocity of some of these seismic waves are slightly lower than what we thought. So we will analyze what this means and which is the implication of this discovery. But before entering in this discovery, it's better to remark which is the inner core, the outer core of our planet. I want to remark that the core, the Earth's core, starts at about 2,900 kilometers depth and goes to the end of the radius of the Earth, which is 6,370 kilometers. So actually, the core is subdivided in two different cores, the outer core and the inner core. The outer core is between 2,900 kilometers depth and 5,200. The inner core is between 5,200 down to 6,300 kilometers depth, circa. So, the important discovery is that our colleagues studied the seismic waves after big earthquake events. You must know that when an event of this kind occurs, two kind of waves, seismic waves, are developed: the primary P wave and the secondary S wave seismics. So, what this means exactly? The primary are the waves that arrive before at the seismograph, and the secondary waves are slower. So, but the important feature of this second type of waves is that they are not able to cross liquids. So this is how geologists and geophysicists in particular were able to understand that the outer core is actually not made by solid, but it's actually fluid. So this is a very important discovery. And the internal part of the Earth is still solid. Although the temperature is extremely high because we are close to 5,000 degrees Celsius, but the pressure is so high that the iron is not able to get molten. So, I repeat, the internal part of the core is solid, the external part is liquid. So now we can explain better what our colleagues from Canberra University discovered. They studied the velocity of the S waves and found that they are actually, with a new method, and they found actually that they are slower than what we thought so far. So which is the implication of this? The implication could be that the composition, the chemical composition of our core is actually not done by only iron and nickel, which is our what we think so far about, what we thought so far about the core. So, to explain this reduction in seismic wave velocity, we can think of some other elements, like, for example, silicon. We can think to other, probably some pockets of fluid inside the inner core, which is not expected. Or, even better in my opinion, because this is what I study, maybe we have some hydrogen still stored in the core, the inner core, that reduce in some way the wave velocity. This will open again a new scenario about the origin of hydrogen in the Earth. Is primary, I mean, it is formed when the Earth formed, or is in some way transported by asteroids, comets from the outer space?